Okay, welcome everybody. Welcome to Innovation Root Studio. I'm your host Noopur, and today I'm really excited to have Larry Maccherone with us. Welcome, Larry, to this discussion.
It's my pleasure to be here, Nooper. Thank you for having me.
So, Larry, before we start with the discussion, let me tell a little bit about yourself to our audience. Larry Maccherone currently leads DevSecOps Transformation at Contrast Security. He speaks and publishes regularly on DevSecOps, Lean and Agile, and analytics, and he is the primary author of a dozen of open source projects. So welcome once again, Larry.
Thank you.
Larry, just to begin with, a very primary question I have for you: what is DevSecOps?
Yeah, it's a good question. I have a bit of a love-hate relationship with the term, as a matter of fact. Um, and the reason for that is that I believe that if you're doing DevOps right, the security part is essentially assumed. So I actually have the same definition for both DevOps and DevSecOps. I just sort of use a little like optional bracket around the sec and the last part of the definition I'm about to give you. And it's all about empowered engineering teams taking ownership of their products all the way to production, including security. So that including security is added as sort of a clarifier at the end, but we don't say including quality. We don't say including performance. We don't give the other attributes of a good system, security just being one of them. I actually think of security as an attribute of quality. And so a high quality product is a very secure product. And the DevOps world, as sort of defined by leaders in the DevOps community, sort of agrees with this. The Phoenix Project, which was the book that essentially launched the DevOps movement, started with the security guy running around the building, basically talking about how bad things were. And yeah, so even the book that kicked off the DevOps movement had security at the very beginning of the book. So
That's amazing. I mean, when you relate security to quality and which is the end objective of any organization. So that's, I think, makes sense. Larry, what inspired you to bring DevSecOps Manifesto?
yeah, so the at the time, the DevOps movement had been essentially, I don't know, almost subsumed, swamped by, maybe is probably a better word, tool vendors who were basically pushing CI/CD tools. And there was this really strong tool mentality um, around DevOps, and I really wanted to shift the language away from a tool mentality and towards more of a cultural transformation mentality. So a little bit about my background. I started a business that did factory floor automation. Our biggest client was GE Power Generation. So our software was controlling 60% of the world's power generation, or involved in the control of 60% of the world's power generation. So if the bad guys could find a vulnerability in our software, they could literally bring down the world's power grid. So we got really good at writing software that was essentially vulnerability free. And the the framework we used to do that was all about enabling and empowering the development team to really own the product end to end, rather than throw it over the wall to a QA department and throw it over the wall to a security department, to try to add those things after the fact. Doesn't work. So Carnegie Mellon got wind of what I was doing and talking about in the industry, and they said, come to Carnegie Mellon. I became a founding member of the Scilab there, founding director of the Scilab there, and we launched this thing called the Build Security In Initiative. And the Build Security In Initiative was really sort of like a set of practice. It was really the framework I used to build the GE Power Gen software, and other control software that we built for other clients. So build security in rather than bolt it on is the first line in the DevSecOps Manifesto, in my version of the DevSecOps Manifesto. And so it's really sort of a fundamental idea. And then the rest of those sort of come from that sort of fundamental way of thinking about security, about it being the development team taking ownership of it and doing it right from the start rather than waiting and having a specialist bolted on after the fact.
Thank you for sharing that with us, Larry. And now I'm coming to the security flaws. It is very important to identify those. In DevSecOps, how does it help to carefully identify the security flaws?
Yeah, I mean, so the idea here is not for a security group to identify the security flaws. And it's not even really mostly for the engineering team to identify them by hand. It's really about taking every security flaw, every defect, every incident, and using it as a feedback mechanism. And you learn from this. The learning effect is really the key here. It's 100 times more effective than what most security groups are doing, because what most security groups are doing is they're just expecting the development team to fix the thing that was found. Well, that's the minimum that a team should do. Fixing what's found is sort of the 1x effect. But there's two other things everyone should do with every defect, with every vulnerability, with every incident, production incident or security incident. They should do three things. They should, of course, fix the thing that was found. Two, they should take that thing that was found and turn it into a bit of a pattern and find and fix others like it, not just in the system that was the target of evaluation for the first finding, but all the systems they own. So I call that a 10x effect. So that's step 2 in the defect, incident, vulnerability 3-step. And step 3, this is really where the power comes in. It's the 100x effect. It's change something about your process, about your tooling, about your training, or maybe not training so much as really sort of learning that the developers have, so that you never create that kind of defect or vulnerability, or you never have that kind of incident again. And so this preventive mindset is really the key to agile working and DevOps working and DevSecOps working. You got to get all the way to the preventive step. Now, for quality defects, the primary preventive step is to add an automated test so that you never do that thing again, and to create a culture of high test coverage. For security, though, I think it's a little bit different, because you can fundamentally change the architecture to avoid the problem much more likely in a security incident. So the quintessential example of that, which is pretty extreme, is you have no risk or very little risk of buffer overflow vulnerabilities, which are sort of the worst case scenario vulnerabilities, if you use a language that's memory safe like Java, compared to a language like C or C++ that you have to sort of manage the memory yourself. So changing the language you write your product in is a fundamental technical change that will prevent you from ever having this whole class of really bad things. Now that's an extreme sort of preventive measure. There's other technical measures that you can do, like turning on CSP, content security policy headers in your web app. They can prevent essentially all cross-site scripting attacks, but you have to do it. But you do that one thing and it prevents hundreds of thousands of potential cross-site scripting attacks. But it's a little work to do that. It's not just as easy as adding the header, because adding that header will actually break the functionality of your app unless you test it right, or you built it with that header on right from the start. So most of the things you do to prevent future occurrence, though, occur between the ears of the developer. So if you feed back the vulnerability really rapidly to a developer, he's like, oh, well, that's easy. I just need to change the way I write code in the future to do this. And the beauty of this particular way of preventing future occurrences is it doesn't just work while the developer is working on the current project. It's effective when the developer moves to another team and works on another project. And if you're the type of culture company that keeps people for a long time, especially, you can have that person sort of affect dozens of projects eventually in the course of their career. And if not at your company, then somewhere else they'll have learned not to do that. The other beauty of this is that rather than send someone to training where they can learn 40 hours of secure code training, it's just in time. It's lightweight. It's 2 to 3 minutes of watch a little video snippet that's integrated with the finding tool. So this one company, Secure Code Warrior, which is a partner of Contrast, my company, if my company's tool finds a vulnerability, it'll link to a 2 to 3 minute video lesson from Secure Code Warrior. And so the lesson is very context sensitive. It's only going to be the ones that the developer actually wrote in the last little bit. And so it's very lightweight as well, and much more focused, much more efficient way, and much more effective way, because they care about the learning for that, because they're trying to get their code out, and so they're going to do it right there. We're sort of like going away for a week to secure code training is sort of in the abstract, and it doesn't really sink in as well.
Yeah, so you mentioned about caring to learn, and you mentioned about a feedback as well. So, in your experiences, have you ever faced any challenge in building a culture for feedback? Like how we take the feedback positively? Have you faced any such challenges in your career?
I have. I think, but my natural sort of the way I am is really sort of about this preventive culture change. And it's much easier to have a conversation with the development team or developer around how you prevent them from writing this in the future than it is to say your baby's ugly, fix these things. And that's a very confrontational approach. And I'm more about coaching. And so my whole program, a bit of my bio you didn't give is that just prior, I've only been at Contrast for a month or so now at this point. Just prior to coming to Contrast, I was at Comcast. I was a distinguished engineer there, but my role there was essentially to launch and scale a DevSecOps transformation program. By the end of that program, we had 600 development teams onboarded to it. And we had data that showed that our program, with a very little investment in human resources, was 6 times more effective than the investment we were making in the traditional security, find the vulnerabilities, call the people's baby ugly, expect them to fix it approach. And it really involved 2 things. Primarily, it involved coaching. So we had a role that I hired for. It was very hard to get the HR department at Comcast to understand how to describe this role. This person is less of a security person and more of a cultural transformation coach. So Scrum Masters were the kind of people I like to hire into this role. And I could teach them all the security they needed to. In fact, the framework we put around the coaching was really sort of had all the content they needed. It was really just about meeting with the development team. So we had this cadence of every 90 days, we met with every development team and we did this workshop for them. The workshop was essentially a list of, we started with a list of about 40 practices, but we would only talk about the 6 most important ones in the first meeting. And we would ask them to sort of say, are you at culture? That was the level of maturity we wanted you to get for this, meaning for every possible instance where this is valuable to do this practice, are you actually doing it? Would you not do it you wouldn't even think about doing it any other way. And then we had other levels of maturity. Actions was the level below culture, meaning we partially do it. Maybe we do it for 3 of our 5 apps, and words is we're making plans to do it, and then thoughts means we haven't really started even planning to do it, kind of thing. And we would start this partial gap analysis, essentially is what it is. Some people would call it an assessment, but that has a negative connotation. It was really for the benefit of the engineering team. Once we found 1 or 2 or 3 of the key 6 practices that were not at culture, we would stop evaluating. We wouldn't make them feel guilty about the other 40 or 30, 34 things on the table. And we would switch into planning mode and says, well, what would it take for you guys to actually get to culture for these 1 to 3 practices? And we would help them make a plan to get to that. And then we would help them over the next 90 days execute that plan. And then they would have it, and they would do it themselves. So we weren't looking at individual vulnerabilities. We were just basically expecting them to have a process by which they detected automatically with tools vulnerabilities, and they very rapidly, within a day, resolved them. And that was essentially the expectation. And there were 40 practices total, so not all of them were about a tool. That was an example. But yeah, and then we would move on to the next 6 most important practices, and we would come back every 90 days until they had a pretty high level of maturity. And teams that went through this program had 85% fewer incidents in production, vulnerabilities found in production. And so that was a pretty effective measure of how effective our program was.
That's interesting. My next question, Larry, is on a very different dimension. So I want to understand how DevSecOps can help in developing resilient IoT infrastructure, the Internet of Things infrastructure.
Yeah, so I'm less of a focused on a particular domain than I am focused on sort of the general concepts of DevOps and DevSecOps. I think IoT has a sort of a little bit different flavor that makes it interesting to talk about from a security perspective, in that at least some IoT devices, cameras for instance, have very sensitive information that they have. And if they're hacked, then that sensitive information can be used by folks to do harm. And so IoT sort of has a bigger attention on this, but the approach is roughly the same. There's a little bit of a difference. Just like when I did Agile transformation consulting, if you have a hardware device where it's very difficult to update in the field the firmware that's on it, or even the hardware that's on it, that's impossible. You have to swap out parts at least. Then you have to do a lot more work up front validating. Whereas with a web app, you can pretty much ship whatever you have, however bad it is, as long as you have a really tight feedback loop. I mean, you're going to ramp up your usage, and the first few users are maybe at huge risk. But of course, the bad guys are not paying much attention to you when you have very few users, so it's very low likelihood you'll get attacked. But as soon as things are found and you rapidly feed those back, you can get to very high levels of security before you have sort of a big exposure to the attackers. The problem with IoT devices is once you ship them, they're a lot harder to fix in the field. A web app you can fix and everybody gets the new web app instantly, essentially, with no effort on the developer team's part. So you do have to shift your mindset a little bit more towards sort of gating to production, and a little less towards ship whatever you got and move rapidly. I do think IoT folks have a very spotty record, though. So at Comcast, we would OEM components for the digital home or the security product. It was really mostly security oriented. So Comcast had a security offering. So if you Comcast Home, you could get a security system from Comcast. But we didn't build most of those parts ourselves. We would take somebody's camera and we would relabel it. I mean, maybe we would add a different color to the packaging or something. The actual plastic around the camera and stuff. But we would have to evaluate these things for security, and it's shocking how little care was put into the vast majority of these vendors' work before we got a hold of it. Some of them were great, but the vast majority of them were just really awful at caring about it. There's sort of very obvious flaws that could have been easily hacked.
Yeah. So coming back to ownership side of um, the leadership or the organization, it plays a very crucial role in the success or failure of any implementation. What is your idea of developing a blameless culture in an organization where the ownerships are sorted?
Yeah, so the DevOps world has this practice called a blameless postmortem, which basically, if you have a production outage, is sort of the most common way this gets kicked off. But if you have a breach, it's also likely to get kicked off. Um, and there's a whole set of guidelines of how you do a blameless postmortem, sort of from the community there. But the one that I think is sort of really super key that gets lost on security people is that it's the development team doing the blameless postmortem on their own work. It's not the security team doing a blameless postmortem on somebody else's work. As soon as you have that external sort of factor involved, it sort of destroys the blameless feeling of it. So you really have to have a culture on the engineering team to begin with of we want to do good work. Now, the good thing is that 85 to 95% of all developers I've ever met care about engineering excellence. And so they don't want their stuff to get hacked. They don't want their stuff to have defects in production. They take it personally when those things are found. So as long as you have that as a starting point, and it doesn't even take an entire team to be that way. It just takes one or two people on the team really to be that way. Come on, guys, we got to do better. We got to not let this happen again. What are we going to do to not let it happen again? That's the key, is what are we going to do to not let it happen again? And it's got to be a we, not a what are you going to do to not let it happen again? And it's got to be not let it happen again. I mean, it basically has to be focused on the preventative. It has to be focused on the step 3 of the 3-step process that I talked about earlier, the learning or technology change or upgrading your testing suite, etc. The vast majority of DevOps production outage oriented postmortems result in a technology change, not it result in sort of a lighter weight, not like a Java C to Java technology change, but sort of a change into your infrastructure. Maybe you auto scale better. Maybe you make an improvement in your testing suite to catch if something like this is going to happen in the future. A performance change will happen in the future. But yeah, so that's the idea around blameless postmortems. Um, if if you sort of take that we to heart, it pervades all of it. It's us evaluating our own stuff. It's the engineering team evaluating their own stuff. It's not somebody else evaluating their stuff.
Yeah. The small difference from you to we can define the success or the failure, I guess, here.
Yeah. Right. It has a completely different feeling when it's we want to do better than you have to do better.
Yeah. So, Larry, if I may ask you one thing, what you suggest should be avoided during DevOps or DevSecOps implementation?
Yeah, so I could answer this sort of on a very low level, tactical level, and I will. I'll give you 2 answers, and then I'll give you sort of more the abstract answer. So on a very, very tactical level, I would say all efforts to provide feedback to the development team. So security still has a role in this future world that I'm talking about. Their role is that of coaches, which we've already talked about. But the second role that I didn't talk about yet is that of toolsmiths. Toolsmiths essentially are upgrading the capability of the organization such that developer teams can self-service new capability like a vulnerability scanning tool in their pipeline, automated pipeline kind of thing. So the tactical mistake that I made when I started at Comcast and I launched the program at Comcast is where I provide that feedback loop. So to me, at first, 5 years ago when I was at started at Comcast, you were thinking shift left. There's no further left than the developer's IDE, right? That's where the code is created. So I focused really hard on tools that detected vulnerabilities in the IDE. And I found after about a year of use of those tools, we had almost no usage of them. And even the teams that were using them, we had almost no sort of really consistency of that usage. It was literally one team that every developer on the team installed the IDE plugin and they basically had clean code because of it. Every other folks tried it and then either turned it off or ignored the red squigglies or whatever from it. So I was like, okay, so what's wrong with that feedback mechanism? And I borrowed some content, some learning from my Agile days around contextual learning. And so contextual learning, it talks about these three domains essentially that have to sort of be true in order for the learning to be truly, completely contextual. And one of them is met by the IDE integrated tool feedback mechanism. And that is that it's important to the work I'm doing today. But the other two are not met by the IDE integration. One of the other ones is that it's important in your social constructs. So for traditional learning, that means your peers care about you, your friends care about whether or not you know this stuff or not, that it's important to them, that you do it. So that's why a lot of people don't learn math, because nobody in their life cares about math. So they're missing that social aspect of it. So, and then the third domain for contextual learning is, and so it's like a Venn diagram where these three intersect, and the sort of a triangular, rounded off triangular in the middle when all three Venn diagram circles overlap. The third one is the organization has to support this. It has to actually align with the priorities of the organization. It doesn't have to just be lip service. It has to really be a priority of the organization. And so integrating with the IDE didn't really effectively accomplish these two others. So we shifted the feedback away from IDE-based feedback to feedback in the pull request. So the way modern development works is developers write code in the morning and they create this thing called a pull request. And the pull request will then kick off the CI pipeline and run a bunch of automated tests for them. And if anything comes back red check mark on that test, they go, oh, wait a sec, I have to fix that before the pull request gets merged into the product later this afternoon. Before I even add reviewers to the pull request, before my peers even see it, I want it to look clean according to the automated test. And so that social pressure was really important. The developer felt like they wanted their new heartthrob, the code they wrote this morning, to look good to their peers, to their friends on their development team when they asked for a code review of it. And they wanted to make sure there were no red check marks next to it when that happened. And so that caused them to do the learning that necessary to actually do it. And then by requiring that development teams have a branch protection status check in their pull requests, that gave me the organizational element. So the answer, the positive to the negative of don't do it in the IDE is do it in the pull request. Give the feedback to the developer in the pull request, not the IDE. And you can give richer feedback there because you can only run sort of very lightweight analysis in the IDE, but you can launch parallel hundreds of containers and run very deep analysis very rapidly in a pull request, which is how we architected our system to work at Comcast. And I recommend people architect to highly parallelize their CI pipelines so that the feedback comes back very rapidly by consuming a lot of compute resources in a short amount of time. But then you share the platform across lots of people, so it doesn't cost you a lot more to do that. So don't do it in the IDE. Don't do it. Do it in the pull request. Don't do it after the pull request. Once it gets merged, the developer's on to the next card in their sprint, and they're less likely to pay attention to it. So if it goes somewhere else and then comes back to the backlog, it could be 3 weeks later before the developer sees it again. Might be a different developer. They care much less about that than they do when they get it right there in the pull request. So that's the tactical mistake I made, and I recommend other folks not make it. The irony is that after we did pull request integration, IDE usage went way up of the tools because they wanted to check it before it got to the pull request. And then it started to come down again because we got better at architecting the pull request to give very rapid feedback. So I'm not sure that's still true anymore, that the IDE integrated tools is not really that valuable anymore because CI technology has sort of caught up with it. The more abstract mistake, and I haven't made this mistake because I sort of started with the agile transformation sort of background before I went back to DevSecOps transformation, is really around language, around word choice, around sort of how you think about the problem. If you think of security as a series of gates of a factory process, where there's an architecting phase, and then there's a development phase, and then there's a testing phase, and then there's a release to production phase. And oh yeah, there might be other features that come along later, but let's not talk about that, because that messes up my mental model. If that's the way you think, then that will come out in your language, and developers will instantly pick up on that you don't know how development is really done. Development is really done by releasing, essentially on the first day of a project, something to production, hello world app, and evolving the framework by which that gets automatically tested and released as it's being developed. And so the feedback loops, the execution of this cycle is really rapid, like multiple times a day. And so you can't think of it as gates in the traditional sense. They're automated gates. Yeah, automated tests are automated gates. But if you think about it as gates, there's a whole slew of things that security people say that just make developers scratch their heads and go, this guy doesn't know what he's talking about. Or he knows what he's talking about from a security perspective, maybe, but that's the old way of thinking about security. The new way of thinking about security is build it in, and he doesn't get it. So you have to really get it as a security person, and you have to really change your language that sort of really proves that you get it. I have a whole talk I gave at the RSA conference this year around sort of the top 10 terms that security people use that make developers scratch their head. So yeah, that's sort of the biggie.
That's interesting. The tactical and non-tactical kind of answers. That's very interesting, Larry. Larry, to conclude this whole discussion, I would like to understand from you, what do you wish for the community for the coming years?
Yeah, so when I was at Comcast, I led the DevSecOps Transformation program. And my job was essentially to scale that program across all development done at Comcast. The diversity of culture, both sort of process-like level culture and human type culture and technology diversity, is super wide at Comcast. We have lots of acquisitions. We have lots of development teams that were sort of embedded in a different kind of part of the company, and they developed a different tech stack and culture. And so I basically learned how to create a framework that was prescriptive enough to be useful, to be guidance to people on how to do it better, but not too prescriptive that it didn't work across that wide diversity of maturity and tech stacks, et cetera. And so I'm packaging that framework right now. It's going to be launched at some point here in a while. I'm not doing it as a Contrast product, but Contrast is essentially supporting me in doing this. But I'm bringing in people from competitors, tool vendors, and other industry leaders that I've worked with to sort of help me build this framework. And the framework essentially will be about the roles you need, coaches and toolsmiths, the practices that you sort of have to have, and the ceremonies you sort of have to go through to sort of make sure those get adopted, and the artifacts, the measurement, particularly measurement that you need to have in order to prove your program works and to provide accurate feedback to development folks. That framework is going to be launched at some point in the next few months, and I hope the community sort of adopts that. I was the co-founder of the Build Security In movement, and then the BSIM was sort of a derivative of that, or related to that, a follow-on to that. BSIM is the Build Security In Maturity model. I wasn't involved in the creation of the BSIM, though. That was a product of a consulting company named Cigital, and particularly the founder of that consulting company, Gary McGraw. He was a co-founder with the Build Security In initiative, along with Nooper Davis, your same first name as you, and I. So the three of us launched the Build Security In initiative for the US CERT, funded by DHS kind of thing. So I'm hoping this framework is going to be a better follow-on to the Build Security Initiative than the BSIM was. I'm hoping that this framework will be more like Scrum is to the Agile world, more like the Scaled Agile framework is to the Agile world, in that it gets very widely adopted, and it is not used as as sort of an assessment tool, but more used as a sort of an improvement framework kind of thing.
All right, that was very interesting. Thank you so much for being with me for this discussion, Larry. It was wonderful talking about DevSecOps Manifesto, about identifying security flaws, about building the resilient IoT infrastructure, and blameless culture, and a lot of things that you have shared about avoiding during the implementation, very interestingly.
Actually, the avoiding one, I have a book chapter I wrote for the epic failures of DevSecOps. And that book actually is just about how people did it wrong and then how to do it right. So you might want to pick up that book. It's on Amazon. So yeah, it was my pleasure to talk to you, Nooper. It's been great. I think it's been a fruitful conversation. Hopefully your community gets a lot out of it.
Thank you so much, and I'm sure people would love this discussion, and looking forward to learn from you more. Thank you once again.
Sure. One last thing, if you'd like to ask me more questions about anything I said here, connect with me on LinkedIn. Larry Maccherone is a pretty unique name, so if you search for me on LinkedIn, you'll find me pretty easily. And I'll be glad to sort of one-on-one talk to you or chat on a direct message on LinkedIn with you.
Yeah, sure. Thank you, Larry.